Hi, I'm Alex Bangs with Biotechnology. Appreciate being back at BioIT World again and the organizers inviting me to speak. My topic this time is about scientific data management systems, and in particular, Veer's journey of setting up an SDMS that's based in the cloud. A little bit about Veer Biotechnology. So we're a commercial stage immunology company focused on infectious disease. Relatively young company, founded in 2016. But have grown to over 400 employees in a public company today. Some of that growth was through acquiring other companies, and that's led us to have multiple sites. It also means we have some things that go in our history beyond 2006, which is an interesting part of Veer's opportunity as far as data goes. Areas we're focusing on include COVID-19, influenza, HIV, and hepatitis B. So part of Veer's, being a startup, early stage, fast growing, getting laboratories set up like in our San Francisco sites. We're bringing in instruments and instrument machines, starting to generate data. And of course, people want a place to be able to put that data, make it accessible to them, to be able to do analysis back on their individual machines. So we set up a file server for that, but file servers aren't great long-term storage solutions because it's harder. You get what I call drift in a file server. So after a while, directories may be organized, sometimes intentionally, sometimes not intentionally. You want to know, can I find this file sometime in the future? So the other thing scientists are starting to do is they're starting to use lab notebooks, which are great. But this is a company where we want to try and be digital, be cloud as much as we can, as early as we can. So one of the things we did was run a process to go out and evaluate and select an ELN that we hoped would work for us across a lot of the different Veer scientific work, and that has proved to be the case so far. So one of the features in this particular ELN that we were hoping we'd be able to do would be to bring the data from the instruments into the ELN entries and be able to have everything all together in one place. However, the particular ELN we got had been adapted to the cloud over time, and its feature set for being able to deal with large attachments was really designed for on-prem and not for the cloud. So we ended up being limited to only 25 megabytes per file effectively, which was a real limitation for us. Now, since then, this ELN vendor has actually been working on a cloud-based solution, but at the time, that was an issue for us. And so initially, ELN records are pointing to the file server, and that's a concern for some of the reasons that I just brought up. So what we really knew that we needed to do was to move to more of an SDMS type approach, where that becomes the place that the instrument data ends up, and have some way of linking that to the ELN. So as we started getting out and looking for this, we thought about, we really want this ability to have this experimental data in an immutable storage, that we want to be able to link it to the ELN, and we want that to be bidirectional, right? You find data in the SDMS, you want to get to the experiment it goes with, and vice versa. Arbitrarily large files, arbitrarily large numbers of files, and be able to have all of this be findable. Think of the FAIR standard in terms of findable, accessible, interoperable, and reusable data. We talked about cloud-based, and then of course, scientist-friendly, so that scientists, we're going to be changing their workflow by using this. Can we make sure that there are enough benefits to the scientists and the workflow is easy enough that it's doable and it will be adopted? So one thing I want to just say about this point about immutable storage and linking these together, in our company in particular, when we think about an infectious disease company, we collect a lot of samples over time. And as I mentioned, some of these companies go back, they're older than Veer. They've got freezers with samples in it from previous infectious disease outbreaks, for example. It's really important to us that we are able in the future to go back and pull something out of the freezer, whatever we know about that, and be able to leverage that and act on it quickly. That's really critical in our area, and it's something that we want the digital environment to support that particular need. So what are we looking at in terms of alternatives? Well, we started with looking at the market leader because it had a connection to our particular ELN. And it had a lot of history that connected it to a lot of instruments, which was great. But the downside, it was not a cloud-based system. It was, although there are companies who have adapted it into the cloud, and that vendor, for all I know, has a solution today, but at that time, it didn't look like a good match for us. The data is more of a SQL Server environment, and that's where the data is kept. And we were looking for something that was more, again, sort of a more cloud-based, think in terms of S3 storage or other kinds of solutions like that. And it required IE as the browser to use it. Internet Explorer is just something we didn't want to introduce into our environment. We did give a little bit of thought to DIY approaches. Could we keep it simple, build what we need? But we knew over time we'd want to add certain features and that it would become a development burden and support burden for IT and for the organization, and that wouldn't be simple long-term. So really we want to look at somebody else who's already made that investment, but something that would match with our needs, and starting it with as something that was really built from the bottom up to be a cloud-native solution. But then we had questions about how is this going to work with the kind of instruments that we're using? How would we get the data into the cloud from there? What kind of features did they have around a data lake to support data mining, data science kinds of efforts in the future? And do they have some ability for us to create what we call collections? So this idea that an instrument may produce for an experiment quite a collection, a whole set of files. We'd like to be able to refer to those in a single way instead of having to refer to 10 or 1,000 files, be able to have a single set that collected them all together. After talking to a few different vendors, we ended up doing a proof of concept with one of these cloud-based solutions. And what we learned from this is there was a heavy emphasis on the instrument side of this. So being able to extract the data from whatever instrument software, being able to do metadata extraction is part of that, which was interesting and useful. Any kind of decoding required so that it would be easier to access in the cloud, and then being able to securely transmit that. There was less emphasis on the data lake features than we were looking for. So they were just starting to have an interface for browsing and searching. And they didn't yet have support for collections. It was sort of a on the roadmap item. It was also using a database for doing the metadata and indexing, and in a way that was less AWS native than we would prefer to do. And so it just wasn't quite fit for us. And lastly, it required instruments to directly connect to the cloud. And we had a strong preference to be able to really isolate our instrument network as much as possible. And so the particular approach used here wasn't as good a fit for us. The good news about doing any kind of pilot or POC is you learn a lot. And so what we decided to do is take a step back and actually do a requirements document at this time. So we're looking at things like what are our workflows today and what's the future state that we would like to see with those workflows when we have a cloud-based SDMS as part of the solution. And what are the use cases that really we get into specifics for those. And so that was things like flow cytometry, what it looked like in terms of running experiments, getting the data from the instrument, getting that into the cloud, then a scientist who would need to pull that information down, use one or more analysis tools, create analysis artifacts, and then how all of that information would get collected together and be able to be linked into an ELN. We of course needed a way to get the data into the cloud, and we were really specified S3 as the underlying data store that we were looking for. And it was important to us to be able to get to that data without having to go through a proprietary software layer to do so. Of course, we talked about the link to the ELN, and we wanted to do this in a way that would be bidirectional, so we could get from the SDMS data to the ELN records that were using it, and vice versa. Important to set up in a way that it could be mined in the future, and key to that was metadata. So how could we tag things and have that as a way to be able to find things within that data lake? And as we talked about, collections being another way of organizing within that and linking. Another piece of this we're looking for is versioning, so that you would have a way to be able to add to data sets over time or have additional data coming in, have some way of dealing with the versioning within the system. APIs, of course, essential for this, for what we were looking for. And then we spent some time also looking at the relative priorities of all these different things. So this was a really useful document for us for organizing our thinking, for helping us have conversations with vendors. And so it was a great exercise that we took the time to do that. So based on that, we now went back out, talked to some of the vendors we talked to before. We found some additional people that we looked at, and it's interesting because of course each vendor has their own different emphasis, and some things realized, oh, it's not really appropriate for this space or doesn't quite fit. But the company that we were most intrigued by, having kind of gone through this process, was Quilt Data. And so we decided to do a new proof of concept project with them. The Quilt system is built on top of AWS services, stores everything in S3, which is exactly what we were looking for. It has this nice interface for browsing data in the cloud. If you go to open.quiltdata.com, you can see a set of open data sets that they have, including some data sets related to COVID. And what's nice is there's an interface that you can sort of get an overview of what's in a particular bucket, and as well as be able to drill all the way down to individual files and see previews of files. So they have different, depending on different file types, ways of being able to access that. They also had this notion of packages, which was great because it really fit with what we were looking for in collections, and I'll talk about that in a minute. The nice thing about doing a pilot or POC is not only you learn the technology, you learn the company, and we were really happy with the kind of interactions we had with the Quilt team. The one thing Quilt did not do is, it was in some ways the opposite of that earlier POC, where it didn't have a solution for automatically bringing data into the cloud. That was our problem to solve. But we felt like, given the kind of data sets we were dealing with, we were comfortable solving that problem, or that we could bring in another vendor to help us solve that problem later if needed. So I want to just mention about packages. As I said, we had this concept of collections, so we could have a set of raw instrument files or analysis files or whatever we're storing, and be able to have a single way to refer to those. So Quilt had that, and they call it packages. What was nice that was additional to that is that packages could have metadata associated with them, so that you would be able to have that as a way to find the whole set of data and not just the individual files. And then that's what you link to with the ELN, instead of linking to all of these individual things. The other thing that was interesting is that packages themselves can be versioned. So if you get additional data, you generate some additional analyses or generate additional raw data, you could revise the package and then be able to point to that. And what's key is that ELN link, we make it to a particular version of the data, so that the analysis that you're showing in the ELN is linked to these particular files in the SDMS, as opposed to, and that allowed more sort of control, if you will, that you could really reproduce and go back to the data that you had referred to in your ELN entry. So as I mentioned, the Quilt system built on AWS. Important to us that the data and metadata stored in S3. As I mentioned, the packages system is something that they built on top of this, but it's actually open source, which is great for us. And then everything is indexed with Elasticsearch, and there's a way to do SQL queries on this as well. So this felt like the right balance for us of a layer that adds value on top of this, but it's based on this foundation that we're very comfortable with storing for the long term. I mean, the key for us here is thinking out 5 years, 10 years in the future. Are we going to be able to still use this particular solution? Are we comfortable with AWS as a foundational technology? Yes. Are we comfortable that Quilt gives us additional added value, but also some level of ability to go directly into AWS as we need to, and it had that right balance for us. So let me talk a little bit more about the workflow for us in Quilt. Here on the one side, we have start with an instrument as the source of data. You could also have the source of data be, for example, an outside partner that's doing some experimental work and then providing it to you, dumping it into a bucket in AWS and start from that point. But we had, we'd either using things like a storage appliance or using AWS Storage Gateway as a way to be able to get the data from the instrument and then get that lifted up into S3. And then from there, get it into instrument bucket, or what we call the kind of raw or instrument bucket, and then collect all of that data there. At that point, the scientists can come into the system, browse and find or search and find that particular data set that they're looking for, pull it down to their machine, be able to do analyses on it with whatever tool set that they want to do. And then they can start to pull together a package. And one of the nice things about this approach is that we're telling people you can do that just with the raw data, but you can also load your final analysis artifacts and workspaces into that file as well. And then all of that gets packaged and put into this in progress bucket. And they may iterate a few times, and that's where the versioning can come into play. And then once they've got a final set of files there, a package there, then they can promote that into this final bucket. And then the package that's in there is what gets linked to the ELN record. So the idea here is this is really this life cycle, if you will, from where you've got this whole collection of lots of different kinds of instrument data, and now it's getting refined by what the scientist is doing in this in progress bucket, and then gets a final seal of approval, if you will, and packaged into final, and that's what gets linked into the ELN record. So just kind of a little overview of once we go down one level into the Quilt bucket, there's a little selector up at the top that can be used to select which bucket you're looking at. Of course, there's a search ability through here, and people are logged in. That's what this is over here. So there's a way for people to, and there's some, you can have some level of control, of course, over who gets to see what. Then this is the particular package we're looking at. And then you can see the metadata that's associated with this package, and then the set of files and folders that are associated with the package. So a scientist can then download this particular package to their machine and do their analysis. They can browse through the different revisions. They can pick a click on and get the link, and then that's the link that they drop into our ELN record today. They can also, if they revise the package, or if when they're initially creating a package, this is the kind of dialogue that they might see at that point. And there they would have potentially different workflows that they can select from, which would also may change the metadata template that is used. So in some cases, there's less metadata. In some other cases, we've asked for more based on the type of experiment or workflow that's being done. And then they can select files, and those could be local files, or they can come from a bucket. And this latter one was really important to us, to be able to pull data directly from the bucket, because if you end up a lot of files or really large size files, being able to have that all stay in AWS and not have to bring anything down to the client was something that was a efficiency saver, just given network bandwidth constraints. So then we talked a little bit at the beginning about needing to be scientist friendly. So we gave a lot of thought to this. And what was great is that the Quilt team was very aligned, and sometimes pushing us to say, you know, are your scientists going to be able to use this? What questions do they have? So that led us to take a little bit of a take it slow approach and do a few different pilots with teams, and then be able to do some different testing of versions with teams, identify pain points, and either make improvements in either what Veer was doing or what Quilt was doing with the system. One of the things early on, as I mentioned, was large file support. We were trying to avoid unnecessary transfers. So we worked to have the bucket-to-bucket transfer capability. Also to have the ability to only upload changed files. So if a scientist pulls down a whole bunch of files, only changes a little bit of information, we only want to upload that delta that really needs to go back up into the system. We also did as many things as we did to help with making it easier to provide metadata. So have templates that are sort of sensitive to what the experiment type would be, pre-populating the data as much as possible where we had context to be able to do that. And then the great thing is using the APIs is being able to automate where possible. So we had a case where we were reading, wanted to get plate data from plate readers, and set up a whole workflow where once that data became available, we would automatically upload it into Quilt. then go ahead and package that via the API and provide metadata that we had based on the experiment that was going on. And then ultimately, when that whole process was complete, send a Slack message to the scientists that would say, here's the link for your particular package. Made it super easy for them to do and really be, fully utilizing the system. And that linking piece is really, in the end, one of the things that really makes this useful and helpful to the scientist is being able to not have to attach a whole bunch of different raw files into an ELN entry, but being able to use that link as the way to go. In the future, we are looking at bringing in more different instruments, getting this rolled out to all of our different sites. The automation process I talked about, we want to make it more automated, that it goes straight from the instrument into Quilt. And ideally, we'll reach the point where each of these, once the workflow gets matured, is remove the file server access for that particular area. There might still be a file server under there as part of the transfer process, but we want to make it that scientists aren't going directly there and they have to go to Quilt as their source for experimental data. We're also looking at how we can integrate this with more bioinformatic workflows to be able to have bioinformatic pipelines go ahead and pull directly from Quilt and potentially be able to put the results back into Quilt. One of the things that we're also looking to do is to do tighter integration with the ELN that we've got. Our ELN actually has a plugin architecture that will let us go ahead and create custom code. And so we're going to work on being able to browse directly to Quilt within that environment. So right within the ELN entry, and be able to select a package. And we're really interested in is being able to then include the metadata in that ELN entry at that time. So that will give us more information to be able to search even within the ELN itself. Lastly, we've talked a little bit about data mining over time, that all of the work that we're doing in terms of organizing the data, and in particular the metadata and the links to the ELN, we see as creating a great future opportunities for data mining. With a lot of these things, that's what you're doing, is you're building for the future. So where we're at in terms of this now is, we've been moving things off of access on the file server and that kind of collection of untagged data into this increasingly valuable collection of packaged data sets. And that's really helping us not only have it work for the scientist who's working on it today, but those future needs we've been talking about. And the process we ran, we engaged with both data scientists and lab scientists, and this becomes the meeting point for the two of them. And that's worked out really well for us, having that participation from both sides. So we've been able to get the immutable storage we want, the packages and linking to the ELN, being able to have that findability for the data and building it on the AWS cloud. This is a quote from one of our scientists that just came up recently that I love. This will be so helpful to future rewrites in 2031 to have links between ELN data and results rather than having to try to piece the information together from whatever clues they're able to find. So back to what I was talking about earlier, when we have in the future a need to be able to go back into our experimental work, data, pull something out of our freezers because now there's a more urgent need related to a particular infectious disease, we want to be able to have all of that information at our fingertips, whether it's 1 year from now or whether it's 10 years from now. And we really see this architecture we're built as making that possible. So I want to thank the team within IT that focuses on research and lab needs that really have helped drive this particular project, and our close partners in data science that were really helpful for us. The Quilt team has been wonderful to work with and great partners for us. And then the scientific teams, of course, we can't do this without them, and their input and patience with us along the way as we tried a lot of things with them, and their enthusiasm about adopting it as we've been putting it out to them has really been great. So that's a little bit about our journey with Quilt and SDMS, and I look forward to your questions. Thank you.